working? Hi. Yeah. Thanks everybody for actually sticking it this far. And I'm honored that actually there's quite a sizable group here. Let's get right to it. So I'm a software engineer at Arista Networks. Friendly, we already talked about that. But yeah, as a software engineer, I work primarily with our software infrastructure team, which as kind of like a startup, it's like a mishmash of tools, infra, and escalations and ops, and like we kind of do like everything jack of all trades style. And today I want to talk about alerts. And before you guys start groaning, I promise I have a point that I really want to make here. I've been working with the software infrastructure group to lead a project where we've installed, not installed, we've created our own monitoring and alerting infrastructure for like the past year. And hopefully I get to share with you guys some of the things I've learned. Yeah, so if you think about alerts, well, there's that boring Merriam-Webster version of what an alert is. But like, you can really boil it down to like alerts is supposed to raise attention to things that really deserve attention, right? But given many different definitions of what alerts are supposed to be, my definition is the systematic method of triggering a critical human response to what's considered technically critical events, right? And I can get like really philosophical about this, but like in my mind, that's already hard enough because like what's technically important does not necessarily mean that technically important for the human person as like a biological thing, right? It's like almost like a cross-species interaction we got here. So it's like more than just like throw the code at the problem kind of issue that you can solve, right? And before I go on, for this talk, I am sort of assuming certain things, just for kind of the sake of brevity of this talk. I'm assuming you guys know about data collection tools, monitoring tools. You have some sort of monitoring enabled for your services, infrastructure. You have some automation or tooling in place that like looks at monitored data and creates alerts. Maybe some tools that let you fine-tune alerts. And methods to deliver alerts directly to engineers. That could be like email, Slack, JHC, PagerDuty. There's tons of ways to do this. And maybe even like automation tools that already like look at alerts for you and like maybe like respond automatically, right? I think LinkedIn has a great example of this called Nurse. But yeah, so I mean, the last one, not required, but yeah, I'm assuming that you kind of know all these things. So yeah, this talk isn't about machine learning. Like I kind of see that as like the cherry on top when you get to that part of having a learning and monitoring pipeline. No data scientists like necessary here. We're just going to talk about how to apply concepts to plain old ops infrastructure group. And also, I'm not going to talk about frameworks or tools here because I consider that to be like the easy part of the problem. Because you can buy vendor products, you can throw software engineers at the problem and just build something, right? And so like in a nutshell, kind of like at Arista, what we've done is we love Influx, by the way, if anybody's here from them. But we built on top of Influx, but we have very, very heavy customization on top of that. But yeah, like that's really all I'm gonna say about tool-specific names and vendors and all that stuff because I find that to be the easy part. Everybody can figure this out. All right, but your takeaways from this talk should be keep your alerts humane. Remember that alerts at the end of the day really are going to human beings. They might be actually sleepy, and they might be like 2 a.m. in the morning where they get the alert, And definitely go over some lessons, like really painful lessons that I learned from like building Arista's monitoring and alerting infrastructure. And just really to hone in the point that knowing how humans react to alerts directly impacts the success and effectiveness of alerts and also consequently your team. Yeah, so, I mean, alerts are extremely powerful tools in your infrastructure, right? It could be about alerts about internal infrastructure, external-facing customer services, internal services, or like it could be just about any pretty much like metrics that you care about and want to be notified about, right? And then the whole point about building out like or investing in an alerting infrastructure so that you have an automated system looking at data pretty much 24/7, better than any human can, and also be like alerted in a timely manner so that the human engineers can get to the problem and solve the issues in a timely manner also, right? And like I think in an ideal world, you have like all these things like working perfectly, and then like you have like perfectly timed alerts, and everybody sees the alert and like understands what the alert's saying, and you get to like, actually fix the outages before it snowballs into an even bigger outage, right? And everybody's happy. No one's really like too stressed out. But like in reality, I find that like actually kind of hard to achieve. Like if anybody has like already like gone and solved all this problem, like let's please talk, because like it's a pretty hard problem in my opinion. And for something so critical for operational success, like they're really hard to get right. And there's also like uncertainties every step of the way while building alerts. And like honestly, I've been with Arista for like 2 years. I'm a fresh new grad before joining Arista. Like so far in my short career so far, this is like the biggest challenge I've had to deal with so far, because you can't just throw code at the problem. I can't just like write up something and expect people to just like it, right? Like it's like and then like for most organizations, like when you talk about infrastructure tools, like people might not even care about it. Like yes, if you have a user-facing tool or user-facing product, people tend to care a lot more about how people see it, right? And of course, no one teaches about this kind of stuff at a university. So yeah, like when you're traveling along this journey of like creating alerts, I think the first uncertainty you face is basically, data. Like if you want to observe some behavior X, right? And how do you even know you're collecting the right data? And you can't possibly collect every single data either. Like that would be a whole lot of noise. And how do you figure out which metrics are useful and which are just adding noise to your alerts, right? And how do you even know like which metrics can you prove with absolute certainty XYZ certain metrics definitely translate to actually accurate alerts at the end, right? When creating alerts on top of them. And I really don't think any one of us can give like a definitive answer as to any of the questions like that I just talked about, but maybe like empirical answers that we've learned from our experiences. And let's say you magically solve the problem of like collecting the right data, and you've like gained some confidence, you tested it out. And next uncertainty is like, what kind of alerts do you want for the original behavior you wanted to observe in the first place, right? Like, which alerts are actually useful? And is it going to be solved by one alert? Because I've never seen so far that like a complex behavior of a system to be solved by just one alert. It's usually like a group of alerts that all work together to notify me of a situation before it happens, or is about to happen, or a critical event has already happened, right? And like, how do you know if your alerts are behaving correctly, right? Like, I think one of the biggest pitfalls of having things so automated all the time is like, it's hard to tell when your automated systems, if they're doing the right thing at any given point in time. It's hard to really prove that with absolute certainty. Like, you can't just do like mathematical equation about it and just like prove it, right? And then kind of like list goes on. And then like, the whole point really I'm trying to drive at this talk is really not even about data or, the process of creating alerts itself even. But like, I think we get, as engineers, I mean, it's pretty understandable why, but like we get so drowned in these technicalities, which are absolutely obviously necessary for accuracy at the end of the day, right? But we kind of think of the engineer as like, sort of like an afterthought, like way off, that might be seeing the alert, need to use the alert, respond to it, right? And like, definitely in my experience, like I've definitely seen some situations where like we don't even think about the end human aspect of this all of it. Like we're just like so drowned in like, oh, are the metrics correct? Like, are the alerts correct? Like, but like, what I've noticed is like, can you actually afford that? Like, can you actually afford to think about the human being at the end, your engineer that needs to see the alert, as like an afterthought, right? And my opinion is no. So beyond analytical challenges you're facing, you ultimately want alerts to cause a response, and like not knowing that you're trying to work with humans here, you just won't know how to make alerts work best for that audience, and your audience is humans, right? And ultimately, if your alerts fail to cause an action by a human, like it really has failed at its job, right? And one of the inspiring points of why I want to talk about this is like I've gone to conferences, I read books, I read papers, like I see a ton of literature on how to get alerts correct, or like, like statistical methods, or like machine learning methods. And okay, that's all great. I'm super excited about that too. But there isn't like a whole just like paper or like book written on like, how to make your end engineers really happy getting the alert, right? Yeah, and then like just keeping in mind, you need to keep in mind that like at the end of the day, you're sending potentially like raw data, or like really technical data directly to a human being and expect them to like respond to it within like 10 minutes, especially if it's like a critical alert, right? Or it might be like literally like 2 a.m. or 3 a.m. in the middle of the night, and you just woke up and you're sleepy, and none of your cognitive senses are up, right? And then you're just like, oh, I don't know what this alert says. Those are all very ineffective, right? And like, I think in hindsight, this is all really obvious, that humans cannot be treated like machines when you cannot just send an alert that you expect like a tool or a machine to understand, and you cannot send the same kind of thing to a human being, right? And in hindsight, I think it makes sense, but like we don't really seem to think about it. So, like at this point, I hope some of you are wondering, why do we care about any of this? Or maybe like you're at a stage where like you're just sending all the service alerts to like some contractor and you really don't care, right? But I think we should care, like honestly, because it's not about having incompetent engineers. It's not about pushing the problem to somebody else. It's not about like any of that. But I think you should care because really not having the audience of your alerts in mind can have severe consequences, especially if it's your immediate team, or even like it doesn't even have to be immediate team, right? It could be anybody that's getting the alert. To name a few, alert fatigue, we'll go into that a little bit. Alerts that make no sense, lack of trust in alerts, and other consequences I've seen from many different like issues that arise is like, people start blaming each other, right? Alerts are ineffective and teammates start blaming each other for the outages that weren't responded to. Well, we're just wasting time here because while we're fighting over each other, the issues that we had are getting worse. They're just snowballing into bigger issues, right? And not just the technical or the business costs of side of this. I've definitely seen that all of this like bad experiences from alerts, like alert fatigue, like I said, alerts that make no sense, confusion, frustration, like all those bad human experiences put together just makes for a really, really ineffective and unhappy team. And your escalation engineers are burnt out, your escalation teams are burnt out, like really just nothing gets done. It's not a good situation. So I want to today talk about how we can optimize our alerting designs and what are the things you should just keep in mind. What are the scenarios that you should definitely try to think about if you are you don't even have to start writing your own alerting pipeline or monitoring pipeline here. That's not what I'm going to talk about. Like if you're just writing that next alert for that service. And what are the things you should think about? What are the things that like I've gone through painfully already that you probably should not go through? And hopefully at the end of the day, like we can all become more humane to each other and a little bit nicer to all of our coworkers. Yeah, so first scenario is I have gotten in this scenario a lot, which is basically, I don't understand this alert. Somebody got an alert, or I've gotten an alert, and I just like don't get it, right? I have no idea what it means. I don't know what it wants me to do. And yeah, like it says, maybe I'll get it eventually, but time is critical here. So this is a great example. I cannot go into details about what Autotest average storage thing is, but it's a type of service that we have. And this is literally an alert that I got at like 2 a.m. in the morning. And I was on escalation. And then it says critical, average storage capacity 9.2 is above 9. I'm just like looking at this, I'm like, great, this alert just told me the number 9.2 is greater than 9. Like I think I could have figured that out myself. And I still don't know why 9.2 is important in this context, right? I have no idea what 9.2 is, why 9 is even important in this alert. Like, does anybody actually can get like, just not even knowing what the service is, what it's trying to tell you, other than the fact that it's mathematically greater than 9? Probably none of you, right? So, I mean, then you look at your alerting pipeline, the automation tools, and the automation tool itself might know what the significance of 9 and 9.2 is, but like as an end user, I don't. As an end engineer, I don't. And it has nothing to do with my competence level. It has nothing to do with my intelligence level. It's just lack of context, and it's a poorly written alert, right? And ultimately, though, the most important thing is how long do you think it's going to take anyone to figure out and track down what that alert is, right? That requires you tracking down who wrote the alert, look up all the documentation, and even then you might not even understand what this alert is still trying to say. And while all that's going on, you're just like, it's like time is ticking, right? It's a critical alert, time has already started ticking, you're probably at like an hour trying to understand what this thing is. 2-3 hours later, you're just like, it's like 4 a.m. in the morning. I'm like, I don't want to, So yeah, like consequences of this is obviously if an alert content is not understandable, like it's literally impossible to react to them, and especially literally impossible to react to them in a timely manner. And there's a whole lot of wasted time on the engineer trying to look at the alert, trying to figure out like what that alert is about or why it was generated. And as I've kind of like ranted a little bit, that there's a whole lot of confusion in my mind trying to understand what this alert is trying to tell me, right? And it's especially frustrating because it's a critical level alert. I should do something about this right now. I can't. And and at the end of the day, it slows down response time by hours. And that's just bad. That's just straight up bad. And I think everybody here can agree with that one. So yeah, rule number 1, please write alerts to be understandable by anyone, right? It should be short and concise. So like what that alert did before is definitely short and concise, but it doesn't have enough details. It has no context of what that is, right? And it needs to have enough context to direct the engineers to the right resources to solve the problem successfully, right? And then like I keep saying, keep in mind, engineers have to read, understand, and react to alerts in very limited amount of time, especially if it's critical alert. And if you're gonna have like values and numbers in your alerts, have the value definitely that trigger the alert in the alert itself, which, this alert did pretty well, but with 9.2. But, short explanation of why that value is important. And, also provide service name or details. It did provide a service name. Unfortunately, in this case, there was no documentation anywhere that I could find, so I couldn't do anything about it anyway. Yeah, so that's 1. Let's move on to scenario 2. Which is every alert is critical. Oh my God, like, does that cause anxiety for anybody here? Yeah. So definitely, I've gotten critical alerts. Like, I had services that just generate only critical alerts. I'm like, why, right? This is like so ineffective. And usually the main offenders of this case is like services with alerts that have like binary states. It's either okay or critical, or it might even have like warning or like various levels, tiers of critical levels, but like just none of them hit. So it's just poorly written thresholds, poorly written scenarios, right? And these just basically generate a stream of critical alerts, whatever some cases hit, rather than warnings or like various levels that you can look at. And the problems with this is like, if you only have critical alerts, right? Like, how do you know which one of them is actually important? Which ones do you even decide to fix first? Can you afford to just like pick and choose which of the critical alerts you want to respond to first? Or do you need to respond to every single one of them, right? Like, where do you even start? At least that's like my response to this when I see a stream of critical alerts. And yeah, so like nothing gets done. Like while I'm being confused about all of this, like I'm not doing anything really productive, right? And so are my my teammates that have the same situation. So it disables issues and problems from being prioritized, which risks actually critical alerts, and there's only ever so few of them, to being addressed in a timely manner, which is like really fast, right? And critical, the level critical becomes completely meaningless, right? And can you afford to do that? Like, when you mean critical, it better really mean it's critical, right? Otherwise, no one's gonna trust that when you say something's critical, that it's actually something worth looking at. And as I was saying, it causes overwhelming stress. I've definitely been stressed out on my escalations when I got like a stream of critical alerts from this one service. And especially some of the dashboards that we have have colors on them. It's like red everywhere. It's like, oh my God. And on top of that, if you actually had tiers of severity levels, you can anticipate when things are gonna get really, really bad, right? Before it becomes even critical, you can see, oh, is it going from priority basically 3 to priority 2, priority 1? You can see kind of like escalation of events rather than just like basically having like a stepping function of events going on, right? So like if you can anticipate critical events before it happens, you can even react to it even faster, right? You can even plan for it. You can build automation around it. You can do a lot of different things. So yeah, every alert must have different tiers of severity levels for different scenarios, and they should actually all hit. And like I was saying, only a few events, at least from my experience, are actually critical. Like if you have just pool of critical events, only probably a few of them are actually absolutely priority 1 events. Don't expect human engineers to respond any faster or any better just because you just like ram them with critical alerts. In fact, actually, you get the entirely opposite attitude. And realistically, engineers can only really respond to like 1 or 2 critical incidents at a time. We just really, literally just cannot parallelize fast enough to worry about that much. And also stress, right? Yeah, that brings me to the next scenario, which is too many and too frequent alerts. And this has to do with noise. So yeah, like you just got 100 alerts in the last minute. Yay, your inbox just blew up, or like your phone's just basically going crazy. At that point, you probably like either sent it to spam, sent it to trash, have mail filters, or you turned off your phone, or like you're just like, I can't, right? And yeah, so like more does not mean effective. Like I've seen teams that like think for some reason that if you send a whole lot more alerts, you're gonna get faster response because it's more critical, it's more urgent, right? It really isn't. So you get alert fatigue, which just basically means you get so tired from seeing so many alerts, you just stop looking at them. It's like basically active avoidance of alerts, right? And obviously alert noise. And as human beings, we literally can't pay attention to that many alerts at a single given point in time. Maybe it's like a tool that can like multi-thread like crazy and look at every single alert. Yeah, sure, we're not that, right? And one other thing that I think is important is repetition is super boring, right? If you see the same alert over and over and over again, most likely you're not gonna even care about the alert or service anymore because it's so boring. Like we want new events to learn from. We want new events to take action on, maybe build new automation around it. But seeing the same alert over and over just basically it's just like you're just drowning in boredom, right? And eventually all alerts, even the really important ones that you should have cared about, just end up getting ignored. And you really can't afford this behavior. So at Arista, what we've done is, like I said, sorry, I can't really get into like the whole details about it, but we have extreme customization in terms of how we can control alert frequency per every single alert, not just at a service level, but per alert level. And so that comes from the idea that every service and every alert has different tolerance level for escalations and critical events. So for example, maybe some internal tool that's just like pastebin or something goes out, generates a critical alert. It's okay for that to be down for like the next 30 minutes. No one's gonna like cry, right? But if our internal like testbed service goes down, oh, that's really bad. That's literally costing dollars every second that thing's down, right? So like that, given that in mind, we have made it completely controllable, customizable. A lot of knobs that you can configure per alert that controls the frequency of each alert. And also, I've definitely learned that every team has a different tolerance level for alerts. So some teams actually might need like that 30 alerts that just got generated to get into action. Maybe they're really like busy, or maybe they're just like not looking at it, or like I don't know what the deal is. But some people really just need that many alerts. And I'm the kind of person that like the first critical alert I see, I'm already freaking out. So like there's already different levels of tolerance levels. So we've also enabled it so that it's per user base. So you can set frequencies for yourself, right? At least in the tool that we have. And lastly, I mean, this is going back to kind of, I guess, like the technicality of alerts, but you might want to revisit your monitor data, how you're collecting the metrics, or what metrics you're collecting, or like how your alerts are even designed. Just very quickly, like static thresholds are just notorious for becoming noisy, especially if you have just like binary static, like it's just like greater than this value, generate critical alert, like extremely noisy. Please don't do it. And one thing that really worked well for us at Arista is every alert that gets added to our repo of alerts that we have, it gets staged. So we stage it for about a week, and during that time, the engineer creating the alert is responsible for fine-tuning it to the best of their ability, obviously, so that we can test for how noisy it's going to be, or even how useful it is. Before going full production, it gets sent to blast it to every single escalation team or anybody relevant. Yeah, scenario 4, the case of I don't care. I think that bullet actually cares about something, but like, oh well. So yeah, unlike machines or just straight up tools or something that's not human, engineers tend to only care about issues that directly affect them instead of like looking at all types of alerts or even alerts that might actually interest them, but they just don't care about, right? And this isn't really about like selfishness or anything. It's like human beings are just inherently most motivated by things that we care about. Engineers respond best to alerts that that are their problem, right? It's their baby. They need to take care of it. So make them own something, right? And engineers respond best to alerts that they know how to respond to. And that's actually kind of going back to my scenario number 1, right? Point them to the right direction. So forcing engineers to act like machines to respond to alerts that they don't care about and like making them look at everything, or even like making them look at all the alerts beyond just like the main critical component for a service that they're responsible for, right? It really results in sloppy responses and non-optimal solutions to critical events, even warning events, any kind of events. That could be due to lack of expertise or due to lack of just caring and not researching what are the best ways to fix a problem. And usually, it doesn't give an engineer enough time to actually respond to alerts that they care about and know how to fix. And they're like distracted by all the other events that goes on, right? And this causes general burnout, frustration, and like when that happens for a long time, it ends up being a vicious cycle of apathy where they just don't care. So what we've done is we provided a subscription model for alerts. On top of the fine-tuning of alerts that we talked about before, I've talked about before, we provide a way for engineers to subscribe to the alerts that they most care about, but we basically hold them accountable for it. You need to own that alert. You need to own the events that are generated by the alert. You need to respond to it. But they have a choice of opting out of other alerts. Not every engineer does this, but they have a choice. For everything else, we provide a comprehensive dashboard or even like digest option, so they get an email or some method of preferred delivery that has all the other alerts that either they can choose to have all the alerts being sent to them or only some of them, but the ones that they're not going to be immediately alerted about right away. This definitely does have a risk. Basically, having a subscription model definitely has a risk of some alerts just not getting any attention, right? And we've definitely ran into this issue before. And I personally really, really believe that kind of gap should be filled in by automation tools, not humans. There should be automation tools, like I referenced, like LinkedIn's Nurse. Automation tools that look at alerts and can apply a known automated action to mitigate an issue, right? Don't make engineers do something they really hate doing or that they don't care about, right? Or you might want to even remove that alert. Maybe if no one cares about it, no one's looking at it, maybe it's just really useless, right? Maybe it's not serving any purpose. And maybe you don't even need it because obviously no one's looking at it and it was fine. Yeah, okay. Last scenario that I want to talk about is cultural transition. This is, I think, the hardest thing out of all the points I'm going to talk about. And I really like this one because it looks like the team is on the same boat, going the same direction. Anyway, so unlike tools or machines, engineers must build trust in alerts pretty much like any other scenario where they have to trust the tool to use it. I've definitely noticed in my org where engineers, they're especially more like used to doing manual monitoring, or they have like some scripts here and there for the service that they own, have a very rough transition to automated tooling around alerting and monitoring. I've had literally huge range in the last year of reception, from like acceptance to reluctance to like active avoidance. They're like, I need to go chase them down. And one of the interesting things about having like an automated tool alert a human is like, you frequently get into this problem of like, oh, this tool's nagging me, right? Would you say that, like, if your manager came up to you and said, hey, I really need you to take care of this case, you probably wouldn't say to his face, like, you're just nagging me, right? Like, that's just straight up rude. But I mean, you're not gonna do that. You're actually gonna start caring about it. But especially when there's like a tool involved, people just kind of like classify as, yeah, I didn't look at it because it was nagging me, right? I don't wanna look at it. And lack of trust really leads to like, obviously one, wasted effort and time and money that went into building the alerting pipeline, because the alerts are not being used, no one's paying attention. Missed alerts, that leads to snowballing effects, just awful escalation periods. And all this like lack of trust, and you know how I said like one of the biggest pitfalls about not caring about humans are at the end of the pipeline is about like how teammates start ending up like blaming each other for problems. This really detracts the whole team from fixing issues that need to be fixed. And they will either blame each other or blame the tool instead of actually spending the time to fix issues, right? Which just really leads to ridiculously high mean time to resolution. Yeah, so for this one, I don't have a magic solution, I'm sorry. But everything that I talked about today, all of that accumulates to building trust in alerts. So like that's having alerts that work, right? Alerts that actually aren't noisy, alerts that mean something that you can actually respond to. If it's a critical alert, it's gotta be critical. And you know, all those things that like, if you put the pieces together, it really starts building trust. And that's definitely what I've been doing. Like definitely our first rollout was like not the, not the most popular thing ever. And then we've iterated over and over and over, and people started to become getting on board. And of course, managerial help does definitely help. But yeah, another important thing is treat, especially your alerting pipeline for internal stuff, right? I think internal tools usually get treated like yet another infra tool. Like, yeah, I want to fix it, but it's kind of like at the back of my mind. I'm too busy doing it. There's like customer cases. Okay, I get it, right? But especially if you have an infrastructure team or a tools team, treat engineers that use your alerting pipeline like actual customers, like precious customers, right? Work on the requested customization features, knobs that they want, and really just like treat them well, and people really start using it. And that's actually what I've seen. After about 1.5 years, finally most teams are on board, and it's actually gained us quite a bit. We have visibility now into a lot of different things that we didn't before. Yeah, thank you. That is the end of my talk. Couldn't be here without the rest of the software infrastructure team, so yeah, thank you.